This simple session will create a machine learning case study using the topics company roster. Here, first of all, create a machine learning case study. We can upload the dataset using this upload method. See the dataset, company cluster. See the CSV file, company dataset dot CSV. Here, first, we use an introduction about this. The name about this dataset. So that way, company clustering. And then we use a brief introduction to the dataset. Here, this business landscape is continuously evolving with companies facing heightened competition, shifting consumer preferences, and evaluating performance metrics. To better understand the underlying dynamics that contribute to success, clustering companies based on their characteristics and UIPs offers located insights. But involve unsupervised learning techniques such as clustering, pattern company, social customer satisfaction, and industry trends can be identified. This analysis will not only help in benchmarking companies, but also in understanding the factors that influence a company's market positions. Here, we use essentially we utilize a dataset of 9,000 companies focusing on their volumes and characteristics to perform clustering. The goal is to group these companies into clusters based on their performance metrics, allowing us to explore similarities, differences, and key insights across various sectors. Tools such as Submit, Learn, Pandas, Number, and Appropriate will leverage to properly process the data, build models, and visualize the results. Here, firstly, is import the key libraries using Number, Pandas, Layers, Macrodic, Seedle, and etc. And then we read the dataset using this function. This is a dataset name, company name, pd.mail underscore csv is a dataset, and we send the shape also. This is the shape in the structure that is basic data view or exploration. Here we find the information of this dataset using this info function. This is the information. After finding this information, we should understand that here there is some missing value exists. And then we print the first file of this dataset using this start helper function. This is the first file of the dataset. And then we check the data size, details of this data size. This is our data types. These are objects for different objects. And we print the botanics and the source data dataset using this function. And the column names using this function. This is the column names. Unnamed zero, name, ratings, lead count, seat types, years, HQ, police headquarters, employees, that's it. And we check the missing value accessibility for the set using this function. Here, I think we'll find the loading is check. Here we find the missing value assist. This C types, this 10 missing value assist, here is 540 missing value assist. HQ is around 90 missing assist. Employees is 9,590 missing value assist. And then we find the percentage of missing values using these functions. So some missing values percentage. And we get the duplicate of this function. And we fill the column names and the unique values of 3. And 2, 3. These are the 3 unique values using this function. Next one is step 4, that is data processing of any missing value handling is required and it drops on the files. Here, using this function, drop function, we drop the unbounded columns, which is the unbounded columns, unnamed 0. And then we check the existed columns using the function. These columns are existed. We drop these using the function. And then we check the distribution of employee columns using these converts. Here, the experts and worries by these counts. This is the final graph. This look here. Then it's a distribution of the years columns using these converts. Their experts years and their years counts. Next, we fill in missing values using this dot fill now function. Here, this asset, there is only 4 missing values exist. Is the type years H2 and values. Here, if you need the missing values using the fill now method, say type years H2 and values. After loading, after we checking the missing values, there is no missing value exist. Here, we fill all the missing values. And then we find the disability statistics using this statistical function. We calculate the mean, median, mode, standard deviation, minimum Q1, Q2, Q2, and maximum, etc. From this is step 4, that is EDA, explorative data analysis. Here we conduct explorative data analysis to understand the data structure and identify key patterns and correlations. Here we create a histogram to check the rating columns. Then we create a box plot to check the rating columns also. Versus ratings. These are ratings displayed in the box plot. And the next step, that is data visualization, we involve these things, express and graph pictures. Here we created, we check the computer ratings using this pie chart. These are the computer ratings displaying this pie chart. And then we create a histogram of the years columns and include the value plots to show the distribution. We have explained CS and value values counts. This is a histogram. This is the value plots. To check the distribution of the years counts. Next, we create a histogram and value plot of the employee column to show the distribution. Here, employee column, axis and Y values count. This is the histogram and this is the value plot. To find to show the distribution of the employee points. Next, data pre-processing here. Now, and we have to get understanding of how the data is distributed and what insight it represents. We can move on the crucial step of data pre-processing. This step involves cleaning and transforming the data to prepare it for analysis. The big input label and cover. Here we define the categorical columns. This is the categorical columns. This is the numerical columns. Here we convert the categorical columns to numerical columns using this function. And we apply the time information using this function. And we check the data set first 5 rows using the function. Here, it is recommended to perform feature staging on the dataset to bring all the feature column to a standard range. This is because the current range of each feature column is different. is different from the other future costs, which can have a significant impact on the model's performance. To achieve this, standard scalable can be used, which is a popular method for scaling numerical data. Every input submit scalar using the function. Then we install skit email. Here we check the rows of these five columns using the function. Here, next we check the data correlations. These are the correlations using the function. Then we first we display the types of each columns and then we identify non-numerical blocks. And then we convert the relevant columns to numeric if applicable. And then we calculate the correlation values. Then we calculate correlations of this data set. And then we create a heat map of this data set. This is a heat map. Here is the columns. This. This is a correlation matrix. And then we use K-mean clustering. Here, the K-mean clustering is a popular unsupervised machine learning algorithm that aims to group similar data points together in a data set. The algorithm takes the data set and the sample number of clusters K. Then it randomly selects K data points to serve as the initial samples for the clusters. If the represents each data points in the dataset to the nearest android, creating characteristics. The way input can be, and then create list to store the sum of squared distance from each k list, and then we fit the candy clustering with the different values of k. Ranges one to another. And then we create a data frame with a k value and corresponding SSD. And then we create a line plot using floating text. This is a plain line plot. Here x value is k and value is SSD. This is a alpha method. K and SSD. Here next we discuss the alpha method. The alpha method is the heuristic feasibility and the function number of clusters using k-means for some algorithms. The method involves plotting the text-prime variations as the function of the number of clusters and taking the elbows of the curves as the number of clusters to use. Expanded version variation is defined as the sum of square distance between data points and the assigned cluster senders, also known as the weighted cluster sum of stories, that is WCSS. Next, we involve Silhouette score and then create a list to store the Silhouette score for each k. Then fit k clustering with different values of k. And then we find the k with higher Silhouette score. Fine, Silhouette score is 2. Then we plot the Silhouette score, which is k. The axis rest k land dash. Here, x is number of clusters, okay, and y is Silhouette score. This is the method. Next is Silhouette method. Here we involve Kalinski, Haradas, and then we plot. So we create an algorithm for plot express. This is a Haradas index. This is a gaming custom visualization, 3D visualization. And then the DB scan. Here, DB scan density basis spatial clustering of applications denoise is a clustering algorithms that pulls together points that are close to each other based on a density rotation. It is particularly useful for discovering clusters of arbitrary shaped datasets that contains noises or outliers. Here we invoke DBSCAN and perform DBSCAN clustering. And then we obtain labels. Yes. We will create the 3D scatter plots within this function. Labels are X, X, Y, stood out, segregate sets. This is type name. We will create the division clustering with the 3D program, scatter plots, circular scatter plot. Here, we define the label with their corresponding capacity values. This is a positive labels, positive level 1, positive level 2, positive level minus 1. Okay, we create separate prices for each level to the corresponding capacity values. When we create a flow using a function, correct? At least x at least is not in the right. After all these operations, through the clustering analysis of 9,000 companies, we have successfully identified distinct group of companies and share common characteristics and performance metrics. The pattern observed in customer satisfaction, risk trends, and or ratings provides actionable insights for companies aiming to enhance their market positioning and operational efficiency. The present approach offers a foundation for deeper exploration into the drivers of success and failure across industries. Moreover, it equips businesses with the tools to identify potential benchmarks areas for improvement and opportunities for strategic growth within their respective clusters.